Hi friends, I am Dr. Dhandapani, MBC Coimbatore. Today I would like to share with you the how to read the part drawings. So the drawing which contains isometric view and orthographic projections, normally any production or manufacturing drawing without the dimension details and other parameters and design data calculations, all those things, and specifically for front view, top view and the cut section view, how we have to represent in the drawings. So those informations already I was discussed in many times, but now we have seen practically how we can read the drawing and what are the representation, how we have to mention it. Let's see now. Let's discuss how to read the drawing with GDNT. Okay, let us look at this drawing. So the drawing which contains the layout, title block, isometric view and orthographic projections, including cut section view and GDNT representations. So any component, if you are going to manufacturing, before that we need a drawing, right? So as a design engineer, mechanical design engineer should know how to read the drawing before doing the drawing or before manufacturing the drawing or before checking the part or checking the component, right? So all the design production quality is very important to read the drawings. Let's see this particular drawing. You can see that this is the layout, and the layout which contains vertically we have like numerical number 1, 2, 3, 4 and here also 1, 2, 3, 4, and the horizontally we have alphabets A to H and here also A to H. This is mainly used for like assembly drawing. So whenever you are going to do the assembly drawing, the location we need to define, right? So easily to identify the location of that particular components or bulletins, so that particular place this layout will be very important. And let us check the title block. The title block always which contains, see the sheet size and angle of projection. Here we have first angle projection and company name and the drawing name, and it is also including heat treatment process and surface finish like RA values, and also for material, what type of material we are using and keynote parameters, scaling, everything, and who is going to draw on this particular drawing, and checking, review and final approval. So all those things which contains the title block. Apart from this is the detailed information inside we have. Like you can see that this is the whatever the blue color it is representing isometric view. This mainly isometric view is used for looking the component, so finally the product maybe looks like this. But before manufacturing we need the detailed information about this particular component. So for that we are going to make orthographic projections. Let us take these are all the sectional views. Here we have a single view. In that view there is the cut sectionals, like this is section AA, right? So section AA we have the detailed informations, and similarly we have section DD and section BB and the detail of C, everything. So if we know these informations, it's very easy to manufacture. Let us check one by one. You can zoom it this particular view. This is the front view. We have the overall dimensions, and this is the height, 22 minimum height is required, and the diameter of this particular hidden line circle, it is around diameter of 45 mm, and the radius is around 26.6, and here there is a radius 14.7, and in this particular hole we have the diameter is around 11.25 with the plus or minus tolerance 0.25, and here there is the GDNT symbol. This is also called as feature control frame, which contains like the initial box we need to specify symbol, and next box we have to represent the like the tolerance, and also the third, fourth and fifth, it's like primary, secondary and third datum planes. Let us say that this is F1 is the primary datum plane, which means horizontal datum plane, it's an F1. With reference to this particular datum plane, we have to represent the position symbol or this particular hole, right? So this is the tolerance we have to provide here. So for that is the reason we have to mentioning these details. Let us see that the cut sectional view is section AA. The detailed information is available here. The section AA, if you cut this particular portion, we have the informations like overall length is around 90 mm diameter, 86 and 50 mm. Here we have diameter of 36, H8. H8 is nothing but the like a tolerance we need to represent on that particular portion. The tolerance detail or tolerance information which is available in design data book in the chapter 3, like limits, fix and tolerance. Okay, if you want to know in depth, then we need to read the detailed information about this particular portion in design data book. Okay, and here we have the datum plane of D6, B1 and B4. The mainly the datum plane is used for making the component its very accuracy with respect to GD&T representation. And here we have the circular hole of diameter 30 mm H8 with the GD&T representation, or the tolerance will be like symbol is perpendicularity, and tolerance here we have given on the primary datum plane. Then this is the symmetry symbol, this is the concentricity symbol, and here we have RA value of, which means surface roughness 1.6. This is the symbol, correct? And the diameter of this zone will be 22.28, and the angle also it is representing, here it's the 3 degree and here 93 degree, correct? And this is the horizontal dimensions like 16 mm, and this is the 13 mm with the tolerance value. And here we have the cut section view BB towards downward side, towards this side there is a cut section view. The section BB, the detailed information is available on this particular portion. So when we cut this particular portion, the detailed information looks like this. These informations easily you can get it through the like the 3D CAD softwares. So the informations like the hole positions and radius as well as the diameter values with the tolerance and surface roughness. So this is the, from the center point to this face we have the 72 plus or minus tolerance of 0.2 and the 40 mm pitch size or pitch distance. And the detail of C we have like that is the chamfer 2 into 45 degree chamfer here we are providing. The detail C is located at this particular place. So the C, the information will be represented here, right? So these are all the major or critical dimensional detail with the sketch cut sectional views is mainly used for making the component or manufacturing this particular product. So the minimum level of understanding is required for making the drawing or making the component or quality check also. Thank you.